Use Ant's Memory Profiler to understand where your memory is going and to locate memory leaks within minutes. Take snapshots of the heap memory and compare results and analyze differences using this summary screen and the class list. Pick a class, then an object. Finally, create an object retention graph to see what's holding your object in memory. Click on the link below this video to download your free trial of Ant's Memory Profiler.
Hello and welcome. My name is Tim Barch. Today I'll be speaking on the specification pattern. The specification pattern is a software design pattern from Eric Evans and Domain Driven Design. It's one of my favorite patterns because it takes somewhat ugly code and allows you to reformulate it and recombine Boolean logic into something that's much more easy on the eyes and still conveys the same intent, and actually, in my opinion, conveys more of the intent than using just nested if statements. You'll see here today we've got a very simple domain. We've got an e-commerce domain with an order, a product, and an address. Inside the order object itself, we simply have order items, which is a list of products, and then we have an address object, which is our shipping address. Obviously, in the real world, you'd probably flesh this out a little bit more and maybe have a billing address and other items, but for today's demo, this is sufficient. One of the things that we want to know on an order is whether or not it's a rush order. Now, the rush order for this particular case is going to be determined by if the shipping address's country is from the United States, the order total is greater than $100. Of all of the items in the cart or in the order, they are all in stock. In other words, the items, there are no items not in stock. The last qualification for being a rush order is that of the items in the order, none of them contain hazardous material. Hazardous material is not allowed to be flown, and therefore we don't want to allow anything with hazardous materials to be considered a rush order, because most likely that order will need to be flown somewhere. These are somewhat rules based on real life scenarios, but yours may change. So here we've got the order, and you can see we've kind of got some ugliness here. We have nested ifs, and if you just look at this code, you kind of got to take a while to figure out what's going on. If the shipping address and then the order total, and there's a lot of things going on here, and it's kind of ugly. So let's go ahead and fix that. What I want to be able to do is instead use the specification pattern. So I'm going to show you how to use it and how it's going to replace this code. We'll then go off and look at how it's built in the framework and then look at the individual pieces. So here I'm pasting in some pre-built code. And basically what I'm going to do here is I'm saying var spec equals new rush order specification, and I'm going to return the spec that is satisfied by this particular order. So what I'm saying is I've got a specification and return whether or not the order we're dealing with meets that specification. So this is very simple. I've got some tests previously set up, and just to double check, here's an order. I said I have a sample order having a domestic address with $200 total, containing a safe product, that means not containing hazardous, that's also in stock. So let me go ahead and run this test just to make sure that everything's working, and then of course it is. So let's take a look real quick at how the framework itself works and what's going on underneath the covers. Okay. First, we have a rush order specification. You'll see here that I've got 5 different specification classes. I've got a domestic order specification, I have a high value order specification, I have an in-stock specification, and a hazardous material specification. You'll notice that those were each of the nested ifs that I had before, and then I have a rush order specification. So we'll take a look at that, and that is the one class that draws all of the specifications together. Here I've defined inside the rush order specification, I've got 4 other specifications. Now, we haven't seen yet how we can chain these together in the details, but we'll get to that in a second. Here you can see we've got a domestic order spec, ANDed with a high value spec, ANDed with the in-stock spec, ANDed again with a hazardous spec that is knotted or inversed. And then we say is satisfied by the candidate, which is the order. So if we looked at our usage back here, we said rush order specification is satisfied by this particular order. This code, the nested if code, is now replaced by, behind the scenes, by a domestic order, and a high-value spec, all ANDed together in somewhat of a readable sense. In my opinion, this code is far more readable than its arrow code or the nested if counterpart. So at this point, you might be wondering, how is this all working? And the root of everything is the specification of order. Okay, all of these classes, domestic order specification, high value, hazardous material, and is in stock, are all specifications that derive from specification of order. Okay, and so each one of those, as part of specification of order, has to derive from I specification. I specification, down here at the bottom of the stack, has one method that really comes into play. It has is satisfied by, and then your Boolean operators and, not, and or, which we've seen and not. Now, when I go back and I look at the specification class, remember we had specification of order implements I specification of T entity. So here I have an abstract. I'm defining it as an abstract is satisfied by, which means any class that derives from a specification of T entity has to implement the is satisfied by method. The other three methods are implemented. It's an and, or, and a not. And you can see I've generically created an and specification, an or specification, and not specification. And those, if you look at the and specification, basically is a composite specification, which a composite specification has both a left and a right that are of the same entity that's been defined above. So when we're dealing with a specification of order, it can take an and specification takes both a left and a right. So then when we look back at the and specification, it must, by rules of object-oriented principles, it define the abstract method is satisfied by. And so you'll see here it's saying return the left is satisfied by the candidate, and then Boolean logic, the right is satisfied by candidate. Similarly, if you look at the or specification, it's doing the left is satisfied by the candidate, or right is satisfied by the candidate. And also the not specification says specification.is satisfied by the candidate, and then not that particular result. So again, each of these small classes make up are able to be composed then together because they all derive from specification of T entity, which has ands, ors, and nots. So as those are being returned, you're able to chain them together. Let's take one more look at the rush order specification. Here you can see we're saying domestic order and high value specification and in stock specification and hazardous spec dot not is satisfied by the candidate. This is the exact same logic that we had before. However, it's more readable. It conveys the intent to the reader and people who might come behind you and make modifications later. It's brief. The original code was maybe about 10 to 12 lines long, and now we've got inside of order down to one small call. It's also more easily updated. If rush order specification changes, for example, if we say that later on it doesn't matter whether or not it's a high value, anything inside of the United States that's in stock and doesn't contain hazardous materials is now considered a rush order. If I can simply come in here and change the logic, and that will suffice and meet the needs going forward. I don't have to change complex if logic or anything like that. I can take these various components and compose them together in any order. Another added benefit is the reusability. An if statement in one line of code can't be reused. What I've done now is I've encapsulated the logic, the if logic, of a domestic, what's considered domestic, what's considered high value, what's considered hazardous, and what does it mean to have something in stock. And so now we can take those and we can reuse those in other parts of our application and have a single point for all of this logic. So I hope you see the value in the specification pattern. If you are interested, I would look up the code on and more research on Wikipedia, or pick up Eric Evans' book on domain-driven design. Thank you very much, and good luck.